Everyone. So I just did the pulley video. If you're after pulleys, go check the pulley video. This will be a quick video on how to make gears in Onshape. And same idea, right? We need these small electric motors to be mounted to and interfaced with the the boxes that we have in the classroom with the camshafts and the cams inside of them. And we want to make our electric motors rotate the camshaft, right? And so how are we going to interface them? Well, that's the challenge here. How the nature of the interface and how we're going to get them to, get the motor to rotate the axle, the camshaft. And you can do it with pulleys, as explained in the other video, or you could do it with gears. Okay, so let's go ahead and get into gears here. And I'm going to create a new document. And I'm going to call it, not very imaginatively, gear or gears. Doesn't really matter. I'm definitely, this is optional, but I prefer to work in millimeters. It's just so much easier, right? So I'm going to change to millimeters. If you want to work in inches, it doesn't matter really. Whichever you're more comfortable with is fine. I choose a plane to draw on, and that doesn't matter. Just choose. I chose the front plane, and I'm jumping ahead of myself here. Don't sketch yet, actually, because we could draw gears, right? We could go ahead and sketch on the front plane and start drawing a circle, and then draw the gear teeth and do the um, circular pattern tool. But it gets really complicated. The angle of the teeth and the width of the teeth and how they intermesh with each other. It's actually really gears get if you want a gear that works well, the nature of the interface between all those teeth is actually sort of mathematically complicated, but computers are good at that kind of thing. And so somebody has written a feature script for this. So let's go. You probably will see this little symbol up there. Let's go to Add Custom Features and go to Feature Script Samples. Single click on it, and then search in Feature Script Sample. I'm going to just search gear, and I'm going to add a spur gear. There it is, version 9. Right, so I'm just going to click on that, and I think I have to click on that again. Let's just see. Yes, it was added to my toolbar. Okay, so I'm done with that. Now all I have to do is, check this out. I just have to choose spur gear, and look, it tells me, I get this beautiful little pop-up box here, and with the depth, that's that measurement there, 5 millimeters, and the number of teeth. There's 25 teeth all around. Module is the pitch diameter divided by the number of teeth. So let's just leave this. Let's just leave that alone. And that's the diameter of the circle here. So it's at 2.5 centimeters. It's at 25 millimeters, and that's about 1 inch. So what we're looking at is about a 1 inch gear here. If you're in millimeters and you're confused, like, wait a minute, I need a 2 inch gear, you can always just write 2IN, right? And it'll do the conversion for you, right? So I just made that a 2 inch gear. And just like in the other video, so let's say this is what I want. I want a 2 inch gear, and then if I want to, I can just accept that, and now I've got a gear. Now, if I want it to fit on the camshaft, well, that's a 1/4 inch wooden dowel. The camshaft is. So I can sketch on the face of this gear, and I can just do a 1/4 inch circle here. Although if the dowel is truly 0.25 inches, this maybe would be better as 0.26 or 0.27, so it fits inside. But you have to write IN afterwards. If you're in metric, you have to write IN so it knows the units. And there it is. So 6.86 millimeters is 0.27 inches or whatever I just wrote. And I can go right up here and remove the material, and I've got a hole in the center. Right? And that would fit onto the wooden dowel that goes through the box. Now, coming out of the motor, so the motor is hooked up to a little yellow gearbox. And coming out of the little yellow gearbox is not a circle, but it's a little rectangle. And I did not measure it carefully, so you have to measure it more carefully than I did these numbers probably will not work unless I'm just really lucky. But I would measure it better than this. I measured it, I just glanced at it, and I see that it's about 4 by 7 millimeters. Sketch on the surface of this gear, choose a center point rectangle, and it's about, keyword there, about 4 by 7. It's about 4 by 7. Extrude, remove, and boom. And that's, again, approximately the size of the little white axle that sticks out of the gearbox. So this gear would now fit, or nearly fit, on the little white axle that comes out of the gearbox. It would fit if I measured this more carefully. I just glanced to show you how to do it. Okay, and that's how you make a gear. So you could do a 1-inch gear, and then you could go here and add another part studio. Maybe this one here is for the is for the gearbox, and if you created a part studio and part studio 2, so let's call this. Oh wait, did I change this? Did I change this one to 2 inches? I think I changed this one to 2 inches. So it's good form to rename these things as you go. I'm just going to call this the 2-inch gear, so I don't get mixed up if I have a bunch of them. Part Studio 2, watch how quick this can be. Front, I don't even know if I have to go into sketch mode. I think I can just go here, spur gear. I don't even have to go into sketch mode. And this is now back to the 1-inch gear, approximately 2.54 centimeters. 25.4 millimeters would be 1 inch. So this is, here's 1 inch. Ready? 25.4 millimeters. There's a 1-inch gear right there. And you could go ahead and put your little hole here, or whatever hole you need. You need a 1/4-inch hole or something a little bit bigger than that to fit on the axle, right? So I can sketch on the face of the gear, and I can choose my circle. And if the axle again is 0.25 actual, then maybe I'd do this as 0.27 IN, and there it is, and remove the material. And now so this one here would fit on the rename. This one here would fit on the 1/4-inch dowel that goes through the box, and this is the 1-inch gear. And this gear would fit on the gearbox. So, you can play around with these things and think about how they would interface. And if you wanted to, you could even put them together in an assembly and animate the assembly. But why don't we leave that as a separate video, because I don't want to take more of your time. I just want to show you how to do these gears quickly. So, you can play with the sizes of the gears if indeed you go the gear route, just like you can play with the sizes of the pulleys if you decide to go the pulley route. We can then animate these gears to see if they mesh well together and all the rest. But I think I'll do that in a third video. So stand by, and here's some help to get you going, though. Okay, talk to you soon. Bye.